Okay, now notice how we can perform a change of variables such that dx is equal to k dt. So we can re-express this integral like so. And if we wanted to, we could divide both sides by the square root of pi to get an integral from negative infinity to positive infinity that happens to equal 1. That's important because I'm going to be talking about the delta function next. Suppose we have a non-negative function. I'm going to call it delta, and we know the upper and lower bound of this function, g, at all places where delta is not 0. Well, g times delta must be somewhere between the upper and lower bound times delta at all places where both conditions are satisfied. And so, if we want, we can plonk an integration symbol and integrate over any domain where these two conditions are satisfied. Well, let's suppose we take delta to be this function here for a chosen value of k. Well, we said just a moment ago that it doesn't matter what choice of k we make, this integral from negative infinity to positive infinity will equal 1. Okay, so this is just 1, and this is just 1. Next, let's suppose we take the limit as k grows without bound. What will this function look like? Well, delta of 0 is going to grow up and up without bound, because that's just k on root pi. But for any other value of t, this limit will actually tend towards 0. And you can check that using the rule of L'Hopital, which states that the derivative of this indeterminate form is just equal to the derivative of the top divided by the derivative of the bottom, and you still take the limit. So the denominator grows much quicker than the numerator. So what does it look like? As k gets bigger and bigger, this becomes closer and closer to an infinite spike at t equals 0. For all other choices of t, the function gets infinitesimally small. Okay? And the area underneath it is preserved. It is always equal to 1. So if a and b are the maximum and minimum values of g at all points where delta is not 0, well, there is only one place where delta is not 0, and that's t equals 0. So that's going to be g of 0, and this is also going to be g of 0. So there is only one thing that this integral could possibly be if we define delta as I've done on the other side of the board. There is only one thing that it could possibly be, and that's g of 0. There you have it, the delta function. So the delta function doesn't really have any meaning by itself because this limit doesn't exist. But if it's put underneath an integration over t, then it does have meaning, and its meaning is to get rid of the integration symbol and set t equals to 0.
Can you read those two, please?